Let's solve LeetCode 46 permutations. Given an array nums of distinct integers, we want to return all the possible permutations. We can return the answer in any order. What is a permutation, you ask? Permutation is a rearrangement of all the elements of an array. Let's take an example. If the input nums is equal to 1, 2, 3, then the output is 1, 2, 3, 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 1, 2, and 3, 2, 1. Why? That's because if you try to rearrange the elements, you will either get 1, 2, 3, which is the standard case, or 1, 3, 2, so 3 is moved from year to year, 2, 1, 3, so 2 is moved in index 1 or index 0, and 1 is moved at index 1, and so on. If you take a simpler example of 0, 1, we can arrange it as 0, 1 or 1, 0, correct? Nothing else. What about 1? There's only one way to arrange 1, and that is 1. All right. So how are we going to solve this? Well, permutation is a very classic backtracking problem. Why is this a backtracking problem? Well, that's because if you just look at the array, let's say 1, 2, 3, how are we going to solve it? Well, we're going to start off with an initial list because we want to build up a list, right? Let's start with an initial one. And then what we can do is, well, you can either have 1, you can either have 2, or you can either have 3, right, as the very beginning element. Then let's go deep into 1. So for 1, we can either have 2, 1, 2, or we can have 1, 3. Isn't that correct? In 1, 2, we can either have 1, 2, 3, and well, that's it. We don't have anything else. And in 1, 3, we can only have 1, 3, 2. Why is that? That's because we cannot reuse any element that's present here. For example, 1 cannot be written as 1, 1, right? Like 1, 1, 2 is not a valid way of rearranging it. Rearranging means that the number of elements should be the same and the total number of elements in an array should also be the same. So when we go to 1, we only have the possibilities of choosing from 2 and 3. When we go to 1, 2, we only have the possibility of choosing from 3. Now let's see for 2, how are we going to solve that? Well, for 2, you can either have 1 or 3. You need to skip out on 2. So how are we going to do that? Well, for that, we can either have 2, 1 and we can either have 2, 3. And then for 2, 1, it can be 2, 1, 3, or it can be 2, 3, 1, correct? Because at this point, only 3 is available, and at this point, only 1 is available for us. And then for 3, it's going to be something like 3, 1, or it can be 3, 2. Well, let's create another array over here. Let's remove this out. Let me erase this. Cool. And after 3, 1, there can be 3, 1, 2, or there can be 3, 2, 1. And that's it. This is the entire solution that you find from here till here. Cool. So how are we solving it? Well, the very first thing is the edge case or the base case, sorry. So how have I decided the base case? Well, for the base case, I'm just carrying over an index. So initially the index is 0, 1, 2, and 3. Or what we can check is that the number of elements in this array is equal to 3. If that is the case, we're done. So let's create a function. First of all, I'll just create a variable result here, and then I'll have a function called backtrack, and what it does is give me the path. Cool. And then I can simply check that, hey, if the length of the path is already equal to the length of the nums, in that case, what I want to do is append to the result. So I have result.append. I'll just have path copied down. I copy it this way so that there's no issue of list referencing. Then I can return it out. And now what I want to do is go over all of the elements that are present in the numbers, skipping the current number I'm on. So I'll just have for num in nums. I'm going over each and every element, but now I want to skip out on this particular element, or actually when I'm on this one particular thing, right? 1 and 2. I want to skip out on 1 and 2. If I'm on this particular element, I want to skip out on 1. Correct? I hope you're understanding what I'm doing. So when we have a list of 1, 2, 3, what we're trying to do is grab all the elements other than the current element that we are on. So when we are on 1, we'll skip this 1 and have 2, 3. If we are on this thing, we're going to skip 1 and 2 and only focus on the 3. Cool? So now, another thing, by the way, what we can do here is if the length of the path is greater than the length of the nums, in that case also I can return. Because if the length of the path is greater than the length of the nums, there's literally no other thing for us to do, right? I mean, as soon as we go to 4 elements, it's going to be an invalid permutation. Cool. So now coming back to this, what I want to do is skip the current element that we are on. Now, how do I skip? Well, to skip, I'll have to pass in another thing here, which is visited. Visited is going to be a set, and we're going to check here that, hey, if the num is in the visited set, that means we've already visited it, we can continue. The reason I can use a set over here is because we want to return all the possible permutations, and we are given an array of nums of distinct integers. Since this is distinct integers, we can pass in a set and it will work. Also, you can also use a list here, obviously, but I'm not using a list because the time complexity would increase because of that. Set would give me the O of 1 time complexity that I need. Cool. After this, what I want to do is backtrack. But for that, first I have to append to the list this number. Then I want to call the backtracking with this thing passed to it. So we have path passed, then visited passed. By the way, we will also have to add number to the visited set. Then we pass in the visited, and after that we'll pop off the path, and then we'll also remove the number from visited set. And that will make our entire solution run. So let me just go out and return the result, and let me call backtracking like that. I have to pass in the path, which is an empty list, and visited, which is an empty set. Cool. So again, what I've done here is gone over every element, and if the element already exists in the set, for example, when we are on 1, we have 1 in the set. When we are on 1, 2, we have 1, 2 in the set. The reason we are using visited and this path both is because visited is a set. Set means it is unordered. So when we want to do result.append path like this, set will not give us the elements in the order that we want. For example, if we store in the order of 1, 2, 3, set can give us 3 to 1 because it's unordered. It literally has no clue about orders. That's how it's able to give us the time complexity of O of 1 to search through it, like if to just search if there's an element present in it. That is one of the trade-offs. And that's why we have to use path so that it is a list that can give us the order, because order is very important here. Order is literally the question. Permutation is just ordering or reordering the elements. Visited is used, which has the same elements as path essentially, but it helps us check this in O of 1 time complexity. Cool. Let's run it and see if that works out. And it accepts. Let's submit it. And it works out as well.